Hi guys, welcome back to the channel Turbo 12. So in this video we are going to see about satellites. So everybody is familiar with satellite. Like whenever we came across the term satellite, we have seen pictures of satellite. We have seen models of satellite in museums, and we have also seen it in a lot of Hollywood movies, maybe Indian movies, I guess. So like satellite, we know what a satellite is. So satellite is an object which is intentionally placed into the orbit. So which is nothing but like it is a computer which revolves around the Earth in a particular orbit. So we have seen images of satellite, but are we clear about how a satellite works or what a satellite is made up of? When it comes to those kind of information, we think like satellite is which is very far reachable to our knowledge, but it is not like that. Satellite system is very simple, and even you can make your own satellite in your house. So in this video, we're gonna see just that. Okay, so what a satellite is made up of? So every satellite has several functionalities. So like every satellite has, for example, if it is a communication satellite, it must be responsible for communication. If it is a weather satellite, it will be responsible for transmitting weather data and weather calculations maybe. So like all these things are done by several equipments on board the satellite. So for a satellite to function properly, it has a lot of equipments or a lot of systems. So we call them subsystems. So these are the 6 generic subsystems which is available in almost every satellites. Apart from these, based on the application of, for example, if it's on weather satellite, these are one or two of these subsystems might change or might be added. So we can see what are the subsystems. So they are structural, telemetry, power, thermal control subsystem, altitude and orbital control subsystem, communication payload. Okay, so I'm gonna explain like what are these subsystems. So structural subsystem. So satellite is not small or very simple as you seem to have seen in any picture or a movie or a model. Satellite weighs around hundreds of kilograms and it carries like very costly and very important equipments to space. So structural integrity is a critical thing for satellites, and this structural subsystem is responsible for that. Like it is responsible for shielding and is also responsible for making the satellite withstand the space conditions. Okay, the next subsystem is called telemetry subsystems. Like as I already told, like satellite has now large number of equipment, sensors, etc. So all these sensors and equipments create large amount of data every minute. So these data must be handled. So telemetry system is responsible for data handling, and also like for example, if you have to control the satellite, we need to give certain commands from Earth's region. So telemetry subsystem is responsible for handling these commands as well. Okay, apart from this, next, power subsystem. So power system subsystem is like an heart of the any satellite system because it is responsible. Without power, nothing will work. So power subsystems consist of power sources. So everybody has seen a picture of satellite. You can see a flap of solar cells. So those solar cells comes under power subsystems. They are responsible for producing electricity from sunlight, which can be stored in a battery, which can be used by all other things. Like power subsystem maintains, controls and correctly monitors like every equipment receives the correct power, and it is also able to save power so that it can be reutilized. Okay, next comes the thermal control. So thermal control, like as I already told, like space might have adverse conditions of temperatures. So when it comes in contact with the sun, when it is very close to the sun, direct contact with the sun rays, the temperature might increase. And when it is in the farthest, like when it is away from the sun, the temperature might decrease or drop even to 0 degrees Celsius. So in those conditions, like there will be adverse temperature changes. So these temperatures, thermal control subsystems must keep all the equipments inside the system at an ideal point so that it can be operating without any errors or without any malfunction. So next comes the altitude and orbit subsystem. So as I already told, our satellites are placed into particular orbit. If it might be low Earth orbit or high Earth orbits, or like it might be a geostationary orbit. So all these orbits are at a particular height and at a particular, like which means particular altitude, and it must have a particular orbital velocity, and it must not interfere with any other orbits of any other satellite. So all these things are carefully monitored by the altitude and orbit subsystems. They majorly consist of gyros, thrusters, some rocket motors. Next comes the communication payload. So as I told you, this is a generic system. So communication payload consists of antennas, like, and without antenna we cannot transmit or receive data. So antennas for uplink and downlink. Uplink is nothing but transmitting data from Earth station to the satellite. Downlink is nothing but transmitting data from satellite to Earth station. So apart from that, transponder is nothing but uh, like a reflector. Like it is responsible for showing us like where the satellite is and how fast it is moving, whether the satellite is operation. So it is nothing but a reflector. If we shine a beam of light or beam of radio waves to the satellite, it will respond. It will transmit as well as respond where it is and how, like, it is like a beacon for locating the satellite. So that's called transponder. So as I already seen, so these are the things. As you can see, these are the parts of any satellite system. Like, okay, as you can see, command antenna, communication antenna, solar cells, batteries, radio, transmission receiver, fuel, motor, thrusters, and camera. So these are the generic parts of a satellite, conventional satellite. Okay, the most important thing here now is, like, according to estimate in 2018, there are around 4,900 satellites in orbit, and out of which only 1,900 is operational approximately. So remaining around 4,000 satellites, or so 3,000 satellites are like not operational and they are still in space. So it means like they are space debris or space waste. So they are equating space pollution. And as you can see, like, in order to tackle this problem, we have to come up with different solutions. There are several solutions, like destroying the satellites in space, but it created many micro particles, micro space debris, which is far more dangerous to other satellites which are in orbit. So in order to solve this problem, we need something which is very small, because these satellites, once launched, they have an operational lifetime of 10 years, maybe several years. After that, they will take another maybe few years to decades to crash back onto Earth's surface, because they have a large momentum in orbit. So it will take a lot of time for them to crash back into the Earth, and they are so huge, so they will leave debris or waste into the Earth surface. So in order to tackle this problem, they created something called CubeSats. CubeSats are nothing but miniature satellites for space research. So nowadays, like, we are able to create satellites which is in the shape of cube, as you can see in the picture, which can be held in hand. So it might be in the shape of cube or any three-dimensional shape, which is similar to cube, and it weighs around with, like, it weighs within 10 kilograms maybe, and it is also consists of like all the operational equipments which are needed. Like, it has a very low lifetime, like maybe around several days to several months, and it is very easily, like, it is very cheap to produce these kind of CubeSats, and they can be easily launched, and they can be easily placed into orbit. So these are all the advantages of CubeSat, and most important thing is that they don't create any space debris, because CubeSats don't have like huge amount of momentum, so they will eventually fall into the Earth, like they will crash back into Earth, or they will fade away within the Earth's their re-entry into the Earth's atmosphere. So this is the advantage of using CubeSats. So trust me when I say this, like, CubeSats are the future for space exploration or satellite technology, because many private firms in US have already started manufacturing CubeSats, and recently we came across CalamSat, which is developed by students, was launched by ISRO, Indian Space Research Organization. So CubeSats are like future, like they are one day there is a possibility that CubeSats might replace an entirely operational satellite. Apart from this, we also know circuits, microcontrollers like Arduino. Even CubeSats can be made from Arduino. They are called AudioSats. So these things help students to create something which is very innovative and which is very helpful to the society. So by this way, you can contribute something to our space exploration as well as to something to the society. So hope you guys like this video. Please like, share, and subscribe for more videos. And we have a Facebook page called Turbo Trial. I would like you guys to like that page and follow us for any updates. So thank you. Have a great day.